class. Welcome back to science. This is our second lesson together, and I wanted to start kind of where we started our first lesson with reviewing a little bit of vocabulary. We started here last time, and we'll also review some of the things we learned in our last class, and then we'll talk about phase changes or changes of state. So to review, we learned what matter is, right? Particles and volume. This is some of our vocabulary. Matter is any substance that has mass and takes up space. So basically all the stuff in the world is matter, right? A particle is a small piece of matter, super, super tiny. We can't see it. And then volume is a measurement of how much space something takes up. And there's examples for all of these, right? So you want to make sure you know what these words mean. We also learned in our last lesson about solids, liquids, and gases. And I've got a couple tables up here just to give us a brief review of what we learned. We learned that solids have a high fixed volume. Sorry, not high, it just has a fixed volume, right? So that means the amount of space that they take up does not suddenly change. Your table does not suddenly grow bigger or smaller, right? This is a new word, density. This is basically how much stuff is packed into the space. So if you have high density, like a solid, that means there's lots of stuff packed into the space. So let's imagine like a liter of something. That's a volume. If you had a lot of stuff packed into that liter bottle, it would be heavier, right? So like a solid filling a liter bottle will typically be much heavier than a gas, which has a low density. There are not a lot of particles in a given space. And liquids are kind of in between moderate to high. Liquids also have a fixed volume, right? They don't suddenly grow or shrink. They always take up the same amount of space. But gases do not have a fixed volume. They will expand to fill whatever container that you put them in. So if you open a bottle that's full of gas in a room, that gas will expand and fill the room, right? The other thing we were learning about with these was their shape, right? And we didn't talk about this word, but we did kind of talk about this, and it has to do with their motion, the motion of their particles, right? So solids have a definite shape. They do not flow, right? Their particles are vibrating back and forth, but they're not moving around each other. Liquids do not have a definite shape. It will take the shape of their container. That's because their particles are flowing past each other, right? Gases also don't have a shape. They will take the shape of their container and they flow the most easily of all of them, right? This is what we learned last lesson. Here's a graphic just to remind us, right? Solids, liquids, gases are three states. To increase the temperature, you will transition from one to the other. And if you decrease the temperature, you'll transition back this way. We're going to talk about these transitions today. And here's another way to look at it, right? This is kind of showing us the particles in a solid. They're all nice and neat and next to each other. In a liquid, they start to flow. And then in a gas, they are free to move around their container completely. Today we're gonna focus on defining each of these terms, right? So melting, freezing, evaporation, boiling, and condensation. So let's talk about melting. Melting is when we change from a solid to a liquid, and the specific temperature at which this happens is called the melting point. So for example, water, ice, its melting point happens at 0 degrees Celsius. So if you have some ice and you heat it up to 0 degrees Celsius, it will begin to change from a solid to a liquid, right? So here's a nice picture of some melting going on, right? This has been heated up to 0 degrees, and it's now transitioning its state or its phase, right? That heat energy that we've given it is making it change from one state to the next state. Freezing. Freezing is a change from a liquid to a solid. So this is happening kind of in the opposite direction. The specific temperature at which a liquid becomes a solid is called its freezing point. Excuse me. And for example, water is 0 degrees Celsius, right? So these often are going to match each other because this is the point at which it changes state, right? The point at which the energies are correct for it to either melt or freeze. Here's a nice picture of freezing, right? These are ice crystals forming on some surface. Kind of looks like snow almost. Boiling. Boiling is when we change from a liquid to a gas, right? And this specific temperature is called the boiling point. And for example, with water, that is 100 degrees Celsius. So if you heat up water to that temperature, it will start to boil. Maybe you've done this when you're cooking something at your house or your apartment. You can see those bubbles starting to form. That is literally the liquid water becoming gaseous and bubbling up and escaping, right? And you get the steam like this that comes out. If you've ever put your hand into that steam, it's very, very hot. And that's because those water particles have been given enough heat energy that they can escape the liquid surface and fly into the air. So they are very energetic water particles flying around in the air. Evaporation is similar to boiling, but it's similar in the way that it is a change from a liquid to a gas, right? But it's different because it happens at a range of temperatures, including below the boiling point. So evaporation can happen for water below 100 degrees. It is much, much slower than boiling, but the higher the temperature, the faster this happens. And you can kind of imagine this surface, right, as the water, as the liquid water, and these particles are the ones that are evaporating. And this happens when the particles on the top get enough energy to escape. So it's the same exact idea as boiling, right? But it only happens to a few particles at a time, or a lot less than what's happening with boiling. So uh, here's a good example of evaporation, right? You put out your clothes to dry, and the sun provides them energy, right? It's providing light, energy, and heat. And over time, the water, the liquid water that's in these linens, um, evaporates, right? It gets enough energy that it can become a gas and escape from these fabrics. So condensation. Condensation is a change from a gas to a liquid. And this also, excuse me, can happen at a range of temperatures. Basically, the gas particles are losing energy, and when they collide with other particles, like for instance, let's say this is water, when it collides with the liquid water, it doesn't have enough energy to escape, and so it gets stuck or it condensates. Um, so as the temperature lowers, the gas loses energy, and then it will get stuck to other liquid particles, right?